GitOps in 2026 is not what it was in 2020. It's not just store your YAML in Git and let Argo CD sync it. GitOps has become the operating system of modern infrastructure, the single source of truth for everything that runs in production. Every configuration, every deployment, every policy, every secret reference lives in Git. The cluster is never modified directly. If it's not in Git, it doesn't exist. And now, AI agents are making GitOps self-healing, self-optimizing, and nearly autonomous. Today we explore why GitOps is the foundation every platform team needs. 4 principles define GitOps. Declarative, you describe the desired state, not the steps to get there. Versioned, every change is a Git commit with author, timestamp, and review history. Automatically applied, a GitOps controller Argo CD, Flux, or similar syncs Git state to cluster state without human kubectl commands. Continuously reconciled, if someone manually changes the cluster, the controller reverts it to match Git. This last principle is the killer feature. Configuration drift, the silent killer of reliability, becomes impossible. The cluster always matches Git. Always. The difference from traditional CI/CD is architectural. Traditional CI/CD pushes artifacts forward, build code, push Docker image, trigger deployment script, hope nothing breaks. GitOps pulls state backward, the cluster watches Git and converges to match. When a deployment fails, you don't run a rollback script, you revert the Git commit. The controller handles the rest. This inversion of control is why GitOps deployments are more reliable. The cluster isn't trusting a pipeline to do the right thing. The cluster is continuously proving it matches the declared state. AI agents supercharge GitOps in 3 ways. First, intelligent drift detection. Traditional GitOps catches manual kubectl changes. AI agents catch semantic drift when your Git config is technically correct but suboptimal. Pod resource requests that haven't been updated in 6 months. Image tags pointing to outdated versions. Network policies that are too permissive. The agent opens pull requests with fixes. Second, automated rollback. When metrics degrade after a GitOps sync, the agent reverts the commit and opens an incident report, no human needed. Third, cost and performance optimization PRs generated weekly based on actual usage data. Repository structure matters. The pattern we recommend, a monorepo with clear separation. Apps directory contains application manifests, deployments, services, ingresses. Infrastructure directory contains cluster-level resources, namespaces, RBAC, network policies. Policies directory contains OPA gatekeeper or Caverno policies. Environments directory uses customize overlays for dev, staging, and production differences. Branch strategy, main branch is production. Feature branches for changes. Pull requests require automated policy checks in peer review. The GitOps controller watches main and syncs to production. Staging watches a staging branch. Clean, auditable, reversible. The GitOps controller landscape in 2026. Argo CD remains the most popular choice. Excellent UI, strong multi-cluster support, rich plugin ecosystem, and native AI agent integrations from multiple vendors. Flux, backed by the CNCF, wins on lightweight footprint and Git native design, no separate database, everything stored in Git including Flux's own configuration. For most teams, Argo CD is the pragmatic choice. For teams that want minimal operational overhead and pure Git native workflows, Flux is compelling. Both support AI agent webhooks for automated PR generation and intelligent sync policies. The controller choice matters less than the GitOps discipline itself. GitOps makes security and compliance dramatically easier. Every change is a signed Git commit, you know exactly who changed what and when. OPA policies run on every pull request, no deployment happens if it violates security rules. RBAC in the cluster mirrors RBAC in Git if you can't push to the production branch, you can't deploy to production. The audit log is Git history itself. Regulators love this. One healthcare company passed their SOC2 audit in half the time after migrating to GitOps because their entire infrastructure change history was a Git log with reviewer signatures. No more reconstructing who changed what from kubectl audit logs. Migrating to GitOps from manual deployments follows a proven path. Weeks 1 and 2, inventory every resource currently running in your clusters. Export current state to YAML. Tools like kubectl need help. Weeks 3 and 4, deploy your GitOps controller on a non-production cluster. Sync your exported YAML. Verify parity. Weeks 5 through 8, migrate staging and development clusters. Train teams on the Git workflow. No more kubectl apply. Weeks 9 through 12, production migration with rollback plan. Most teams we track complete full migration in 12 weeks with zero downtime. The key insight: you don't need to rewrite everything. Export what exists, commit to Git, let the controller take over. 4 pitfalls to avoid. 1. Secret management. Never store secrets in Git. Use external secrets operator or sealed secrets. 2. Sync wave ordering. Complex deployments need resource ordering. Use Argo CD sync waves or flux dependencies. 3. Monorepo versus multi-repo religious wars. Pick one based on your team structure and move on. Both work. 4. Ignoring the human workflow change. GitOps isn't just a tool, it's a discipline. Developers must stop kubectl applying. Platform teams must review infrastructure PRs with the same rigor as application PRs. The tooling is easy. The culture shift takes longer. GitOps is the future of infrastructure management because it makes infrastructure as reliable, auditable, and reversible as application code. With AI agents on top, it becomes self-healing and self-optimizing. If your team is still running kubectl apply in production, you're one mistaken command away from an outage that GitOps would have prevented. Start your inventory this week. Deploy a GitOps controller on dev next week. The path is clear, the tools are mature, and the ROI is measured in prevented outages. I'm AI DevOps Daily. Next episode: Zero-Touch Incident Remediation with AI Agents.